to the online video lesson on diodes, semiconductor diodes. So in the previous video, I taught you what a diode is and the structure of a diode, how it's formed, how it's manufactured. You watched the short little video. Hopefully you gain a better understanding of why a diode only allows current to go in one direction. Okay, so today what we are going to do. Okay, sorry. Welcome back. Slight technical difficulties, not technical but biological difficulties. Okay, so as I was saying, diodes, right? So today we are going to learn how diodes behave. Okay, so follow us as we use your textbook. Okay, so as we were saying, a diode, let me annotate. Okay, a diode allows current to flow in one direction. So specifically, in the anode, current flows through to the cathode, right? So the voltage across the diode is called VD, yeah, and the current through the diode is called ID. Now, when VD is positive, it is also known as the forward voltage. Now remember, if I have a P and junction, a depletion region is created, right? And we want let me change the colors here. Let's use a nice bright orange. If I want if I want more of the negative charges to cross over into the positive charges, they need some form of energy to kind of pull them across. Yeah, this is called the knee voltage or the forward voltage. Remember, I need some extra energy, the voltage, to pull them across the depletion region. If not, the depletion region is going to be kind of like a barrier to prevent these guys from going over. There needs to be some external energy source to pull them across. Okay, so this is a symbol of a diode. Remember how to draw it? Okay, so let's take a look at when the diode is forward biased. That means that the current is able to flow through. Okay, so I need to place my diode in a forward bias arrangement. In this case, how I remember is that the direction of the arrow of the diode, so to speak, follows the direction of the current. So yes, current is able to flow through, and therefore the bulb lights up. So this is called forward bias, okay? But if I place the diode in a reverse direction, like so, now the current would want to come over here, but then it meets a barrier and therefore no current flows. So in this case, we say that the diode is reverse bias. So no current will flow and therefore the bulb does not light up. So we need some sort of a model to help us learn and to study the diode. And the first model that we are going to take a look at is called an ideal diode. It's called an ideal diode. And what an ideal diode model, let me highlight this. So what an ideal diode model does is that it treats the diode when it is a forward bias as just a very simple short circuit closed switch. Okay, it closes the switch. And when it is, so this is forward bias. Oops, I did not want to do that. How do I redo this? You know what? Forget about highlighting it. I'm just going to underline it. So this is when it is forward bias. It acts as a closed switch. So current goes and goes and goes. But when it is in a reverse bias, remember the current is not able to go through. Therefore, it acts as an open circuit and no current flows. So this is what we call an ideal diode model. And if I were to draw a IV graph, this is the IV characteristic graph of a ideal diode. One more time. We are still talking about using the ideal diode model. Okay, so what this means is that if it's in a forward bias, current is able to flow. There's no limit to the current. It just goes and goes and goes, right? It theoretically goes to infinity. But if it's in a reverse bias arrangement, no current flow, so zero current flows. Okay, so this is a ideal diode model, and it uses this IV characteristic. Yeah, you can take a read about this. What I've explained is explained over in these two paragraphs. All right. So this is a very, very good model for a very quick analysis. You either take it as a open circuit or open switch or a closed switch. However, uh, it is too ideal. Let's put it that way. There are some missing elements that we do need to consider when we study diodes, and therefore we actually very seldom use the ideal diode model. So I'm going to pause here. I want you to kind of go through this ideal diode model, understand it. It helps you do a very, very rough analysis. But the next part I'm going to teach you is called the practical diode model. Okay, so one more time, look through this video. If there's anything you're not sure, email me at yo_hake_jean@sass.sg. Okay, so I'm going to stop the video here, come back for part 3.